All right, so continuing 6.1, properties of exponents. So we're going to deal with three things today. Multiply exponents. So you will multiply numbers in the front and add exponents. Okay, so how do you know if you're doing a problem that is multiplying? It could look two different ways. So you could have the dot in the middle. So the numbers in the front, 2 and 3, we just multiply those together, 6, and then add exponents. Okay, so if there happen to be, let's see, if it's a multiply problem, you could also have parentheses. So if you have multiple letters, just do each thing by itself. So the numbers in the front, -3 times 4 is -12. The x's, a 2 and a 3, add the exponents. And then 4 and that's a 1. So remember, if there's no exponent, it means it's a 1. So -12, x to the 5th, y to the 5th. Okay, so parentheses or, excuse me, the dot in the middle. Okay, so I'm trying to see if you have any. Yeah, so we could have all right, sorry. I had to pause the video for a second. So we might have negative exponent in there, and that's okay. So 2 times 4, 8. And then we're going to add the exponents, or just combine them, really, if you want to think about it like that. So what we're really doing down here is 3 plus -5, which would be -2. So 8x to the -2 power, excuse me, can't have a negative exponent in our answer. We talked about that yesterday. The 8 is fine. So I just moved the x part to the bottom. So some people want to make the -2 go with the 8 also. If there were parentheses around the 8 and the x, then yes. But there's not. So the 8 stays where it is, and then just the x part would move. Okay. If you had one, and this kind of trips people up sometimes. Okay, the 2's are like the x's in this previous problem. They're not like the number in the front. So we're not doing anything. They're what's called the base. We have a base and an exponent. We never change the base. So this is just 2 still. And then -4 plus 7 is 3. And then most of the time the book wants you to multiply it out. 2 times 2 times 2 is 8. Not 2 times 3. Now we're doing 2 to the third power. We're multiplying 2 3 times. Okay? So there's a couple that have numbers and not x's or y's or stuff like that. All right. So multiplying exponents. Multiply the number in the front, add the exponents. Okay, dividing with exponents. Okay, you will divide or reduce. And we kind of did that yesterday. Divide or reduce the numbers in front and subtract exponents. So, and not all of them will have a number in the front, but if you had, x to the 5th over x squared, you're just going to do 5 minus 2 is 3. And so there is like a visual that you could look at for this, and I'm going to show you this to show you something in a second. But so these reduce and these reduce, and you're left with 3 of them. Okay, so if you had it the other way around, you could still say, okay, 5 minus 2 is 3. But since the 5 is on the bottom, and that's like the biggest number, then we have to do that. Okay, because this is, the visual is the opposite, where these reduce, and there's 3 of them left on the bottom. Okay, you could look at that as 2 minus 5 is negative 3. And then, I can't have a negative exponent, so I put it on the bottom. There's several different ways to kind of look at it. If the numbers are positive, subtract them. And wherever the biggest number is, so in this case the 5 is bigger than 2, the 5 is on the bottom, so put your answer on the bottom. On the first one, the 5 is on the top, so it's like over 1, but you don't have to put that. So it's just like that. Okay. If we had like that, we kind of did a little bit of this yesterday, where the 2 and the 8, we just reduce it. I can divide both of them by 2. So that's where the divide or reduce part comes into play. And then subtract 3 minus 1. So remember that if there's no exponent, it's really a 1. X to the third and x to the first power. So 3 minus 1 is 2. Okay, and so if you wanted to erase the 1, you could, and just have x squared over 4. If you had 1x squared over 4, that's fine also. Either one is fine. All right. So when you're dividing, it's going to be a fraction. Divide or reduce the numbers that are in front, and then subtract the exponents. So just like the last one, if we had 3 to the 4th power and 3 to the 2nd power, the 3's and those aren't numbers in the front because there's an exponent attached to them. If you look at the 2 and the 8 over here, there's no exponent with them. It's just a 2 and an 8. These have exponents, so we would write this as, 4 minus, or subtract the exponents. 4 minus 2 is 2. And 3 to the 2nd power is 9. All right, and then one last thing that I almost forgot. I said yesterday I'd explain why 0 power equals 1. A lot of people want to say, well, wouldn't it equal 0? Makes sense. So if you divide, like if I did 10 divided by 10, that's 1. If I did -5 divided by -5, that's 1. So as long as you have the same thing that you're dividing with, the answer is 1. I could, 2.4 divided by 2.4 equals 1. It's the same thing. Okay, so that's where if I had x to the 8th power and x to the 8th power, well, that's the same, something divided by itself, or the same thing, just using this pattern that we started with. Well, that would equal 1. But if we look at, well, I'm supposed to subtract the exponents, well, 8 minus 8 is 0. And anything to the 0 power equals 1. Okay, so really, like if you saw something to the 0 power right before that, you would have had exponents that are the same on top and bottom, which would mean you're dividing by the same thing. Okay, so that's why it works. I'm a believer that it's important to know why stuff works and not just memorize stuff. All right, so one more thing. So in the book, they call it power of a power, and I'm fine with that. I call it power to a power. Okay, and you're going to do the number to the power, or the number in front, and then you will multiply exponents. So sometimes you might be thinking like power to power, like what does that look like? So if I had x to the 3rd power, and then I had that to another power. Okay, so if you kind of back it up and think of like, what does this really mean? Well, it means x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd. And now I've written this out as if it's a multiplying problem, and we're supposed to do 3 plus 3 plus 3 plus 3. That would be x to the 12th power. Okay, but we don't want to have to write all that out. So if you multiply the exponents, 3 times 4 is 12. Okay, so if you had I don't like that one. Let me change that. Let's do that to a 4. Okay, so 2 to the 4th power, number to the power, so the number in the front, 2 to the 4th power, 2 times 2 times 2 times 2. We did that like a little yesterday, but you get 16. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Multiply the exponents, we get 16 on both of them, but 4 times 4 is 16. Okay, so if we had, 3x squared, I'm going to change that to a 4. 3x to the 4th power squared. So 3 to the 2nd power is 9. Multiply the exponents, and we get 8. Okay. I don't see anywhere they have, just to like throw it out there. If we had 2 x to the 4th, y to the 3rd squared, well, 2 to the 2nd power is 4. Then multiply, it's like you're distributing. I'm going to do to the 2nd power there, I'm going to do the 2nd power there, I'm going to do the 2nd power there. So x to the 4th squared, 4 times 2 is 8, and then y, 3 times 2 is 6. So just do the exponent to each thing separately. All right, and then this is kind of a combination. The last few problems, maybe not that many, but it's a combination of things. So if we had 2 over x to the third power, and then a 3 on the outside like that. Okay, so just do what you need. It's kind of like distributing. We're going to do to the third power on top, and then we're going to do third power on the bottom, separate. So 2 to the third power, 2 times 2 is 4, 4 times 2 is 8, and then multiply exponents. Okay. So here's kind of a different one. Okay, so what do we do with a negative exponent on the outside? Well, negatives we like flipped, and then we made the exponent like positive. So what I think is the easiest thing to do is just flip the whole thing like that and make the exponent positive. And then do the problem like the first one. So 4 to the second power is 16, and x, remember that's like a 1, so 2 times 1 is 2. And that would be the answer. Okay, so there's a couple of them that have a negative exponent. I would just flip it right away. Okay. Oh, I noticed there's one like this. This is kind of going back to the previous screen, but if we had 2x to the third power, and then what if we had negative 3 like that? So really what this is saying is like 2 to the negative third power. I'm distributing. And then I'm going to have x to the third. Well, my rule says that I'm going to multiply exponents. Okay. So 3 and negative 3 is negative 9. Well, then with negative exponents, the other day we said, well, we're supposed to put them on the bottom. And so since they're both negative, I'm going to move them both to the bottom. And now I can actually I can't do 2 to the negative 3 power. I don't know how to do something negative 3 times, but now I can do 2 to the third power is 8, x to the 9th. Okay, so you could just start off by putting the whole thing on the bottom. So here's like another way to think of it, is just to say, well, there's a negative exponent on the outside, so all this just comes down to the bottom. 2 to the third power is 8. 3 times 3 is 9. Because the parentheses are grouping the whole thing, I can just move the whole thing to the bottom. Okay? So a little bit more involved, but still the problems go pretty quickly. There's not a ton to do with them. Okay? So just remember, multiplying, you'll see the dot or parentheses. You're going to multiply the numbers in the front and then add exponents. Dividing will look like a fraction. Divide the numbers in the front or reduce the numbers in the front. Subtract the exponents. And then a power to a power, you'll have a parentheses and then an exponent on the outside right away, like these 3 examples we did here. Okay, do the number to the power and then multiply exponents. All right. Hopefully that makes sense. If not, please stay tomorrow on the Zoom and we'll go over some stuff. Have a great rest of your day.